Hello, welcome guys. In today's tutorial, I'm going to take you through normal distribution. Without wasting much time, let's start. Now we say a normal distribution is a continuous probability distribution for a random variable x. The graph of a normal distribution is called the normal curve. For you to understand this normal distribution better, it's important we look at the characteristics of the normal distribution. Now, the first property of the normal distribution is the mean, the median, and the mode are equal. Okay, so in a normal distribution, the mean is equal to the median, is also equal to the mode. Okay, and also, the normal curve is bell-shaped and is symmetric about the mean. What this means is that the normal curve has a bell shape. Okay, it has a bell shape, and also it is symmetric about the mean. It means that when the curve is divided into two equal halves, okay, the middle is where the mean is located. Okay, the mean is at the middle. And also, the entire family of the normal probability distribution is defined by its mean, which we use mu to represent, and its standard deviation, represented by small letter sigma. Okay, and also the total area under the curve is equal to 1. It means that the entire area under the curve here the entire area under the curve is equal to 1. Now, another property of the normal distribution is that it is asymptotic. It approaches the x-axis but never touch the x-axis. So that is why when I was drawing, I didn't allow the curve to touch the x-axis. You see that? And also, between mean plus 1 standard deviation and mean minus 1 standard deviation, the graph curves downwards. The graph curves upward to the left of mu minus 1 standard deviation and to the right of mu plus 1 standard deviation. What this means is that where the curve is turning downwards at this point, okay, and then when it is turning upwards at this point, when you trace this downward, it is mean minus 1 standard deviation. And then when you trace this downward also, it is mean plus 1 standard deviation. So you realize that this point and this point, they have the same height. Okay, they have the same height. So this point and this point, we call them inflection points. Okay, inflection points. So look at how it looks like, as you can see. Now, in exams, I can give you a question like this. I'll draw a curve like this and then ask you to find the mean and the standard deviation. Whenever you have such question, this is what you do. You look at the turning point of the curve, okay, then you trace it downwards. So when you trace it down, you realize that it's at the middle of 3 and 4, which is 3.5, okay. So the mean is 3.5. And then to get a standard deviation, you are going to take the first point of inflection here. When you trace it down, it falls on 5, right? So you check for the difference between 5 and the mean. So 5 minus 3.5 will give you 1.5. So that is the standard deviation. You can also check it with this. This is another point of inflection. And then when you check it to the mean, 3.5 minus 2, it also gives you 1.5. You see that? So the standard deviation is 1.5. Let's check it for this. Look at the turning point. When you trace it down, it falls on 3.5. So the mean for this is also 3.5. And then the standard deviation will be, let's check where the point of inflection will fall. Okay, this falls on, I think, 4.2, right? Now, 4.2 minus 3.5, you get 0.7. So that's why the standard deviation is 0.7. Okay, you can check it for this side also. This will be 2.8. Okay. Now, 3.5 minus 2.8 will give you also 0.7, okay. When you come to this also, when you trace the turning point downward, it falls on 1.5, so the mean is 1.5. And then to get a standard deviation, let's check. When we trace this downward, we get 2.2. So 2.2 minus 1.5 gives you 0.7. So that's the standard deviation for this also. Also, in exams, I can give you this also in exams. And then I name this curve curve B, and then this curve curve A. So let's say we have 1 here, 2, 3, 4, 5, 6, 7 going. Okay. If I ask you that which of them has a higher mean, the answer is this B. Okay. The reason is that when you trace the point down, it falls on I think 5.8 or 5.9 or 6. When you trace this also down, it's on 3.8, right? So this was 5.8 and this 3.8. So this has a higher mean than this. Okay. But if another question asks you that which of them has a higher standard deviation, the answer is A. The flatter one has a bigger standard deviation than the taller one. Okay. So whenever you see such question, you should be very careful and answer it properly. Then let's look at standard normal curve. Now, there are many normal distributions, each with its own mean and standard deviation. So when you look at this, they all have their own mean and their standard deviation, isn't it? But the normal distribution with a mean of 0 and a standard deviation of 1 is called a standard normal distribution. Now we have a normal curve which its mean is always 0 and its standard deviation must be 1. And that normal distribution is called standard normal distribution. For this particular one, you realize that this is x-axis, isn't it? We can convert this to a standard normal curve. But when we are converting it, it means we are converting this x to z. Okay. So we can convert this also to a standard normal curve. So let's look at how to do that. Now, before you can be able to do that, you need to know the formula for the z. Now, the z is equal to x minus mean divided by standard deviation. That's the formula. So let's convert this normal curve to a standard normal curve. Now, I'm drawing this same curve. Now, this is a normal curve, okay? It has a mean of 3.5 and a standard deviation of 1.5. So we want to convert it to a standard normal curve. Note that this is x-axis, right? But in a standard normal curve, it won't be x-axis anymore, it will be z-axis. So we want to convert the x values to z values, okay? Now, take a look at this. What was the mean? The mean was 3.5. So let's first convert the x value of 3.5 to z value and c. So to convert it, let's use this formula. So our x is what? 3.5. And then the mean is 3.5. So minus 3.5 divided by, the standard deviation is 1.5. So 3.5 minus 3.5 will give you 0. And 0 divided by 1.5 will definitely give you what? 0. So this line, when you draw it here also, it means that this 3.5 here has been converted to 0 in z form. So that is why the mean of a standard normal curve is 0. Then let's check for 4 also. Now for 4, you have 4 as an x value minus the mean. The mean is 3.5 divided by standard deviation of 1.5. So this will give us 4 minus 3.5 is 0.5, isn't it? 0.5 divided by 1.5 will give you 1 over 3, which is the same as 0.33. So this 4 will now change to 0.33. Okay. Also, let's check it for 5. 5 minus 3.5, then we divide it by 1.5. 5 minus 3.5 will give us 1.5. And 1.5 divided by 1.5 will give us positive 1. So 1 will be here. Going in that manner, you do it for 6, 7 going. Then let's come to the left side. Now at the left, we have 3 here, isn't it? So let's take it. 3 minus the mean, 3.5, divided by standard deviation of 1.5. This will give us negative 0.5 divided by 1.5, isn't it? Then in decimal, it becomes negative 0.33. So it will be at the left, negative 0.33. Let's check it out for 2. 2 minus 3.5, that is the mean. We are following this formula, okay? Divided by standard deviation of 1.5. Now, 2 minus 3.5 will give you negative 1.5. When you divide it by 1.5, you get negative 1. So you realize that in a standard normal curve, the right side is positive, the left side is negative, and the mean is 0. So that's the difference between standard normal curve and a normal curve. So you can do same for this curve and do same for this as well. So in this video, we are going to use something we call the Z table. Okay. So now let me show you how to read the Z table. So kindly take your Z table and follow me. Now the one at the left is a positive Z table, and then the one at the right is a negative Z table. But take a look at this also. This is also a Z table. But how to read this particular Z table is different from how to read this one. This is mostly used by continuing students, and this is mostly used by first years. But I've explained how to use this in one of my videos. But in this particular video, I'm going to explain how to use this Z table, and I'll be using this particular. I call this Z table a full Z table, and then I call this one half Z table. The difference between them is that when you look at this one, the first area is 0.5000, which is the same as 0.5000. Okay, so the first area is 0.5000. And then when you look at its negative, look at the down. You see it's also 0.500 at the down. 0.5000, isn't it? But let's look at the one I call the half Z table and see how it starts. Now look at the half Z table. You see that it starts with 0.0000. It's not 0.5000. You see that? So how to read this particular one is different from how to read this. Okay, but in this video I'm using this particular one. In one of my videos I've already explained how to use this Z table. Okay, so let me tell you how to use this Z table. Now I want to give you some 4 guides on how to use this table. So kindly take a pen and paper and write it down. Point 1. When you check a positive Z score on a positive Z table, the answer means the area from that positive Z score to the left of the curve. Please write it down. This will help you understand how to read the table. Then point 2. When you check a negative Z score on a negative Z table, the answer means the area from that negative Z score to the left of the curve also. Then point 3. When you check a positive Z score on a negative Z table, the answer means the area from that positive Z score to the right of the curve. And the 4th point, when you check a negative Z score on a positive Z table, the answer means the area from that negative Z score to the right of the curve. So let's take some questions and then see how to do that. So question 1. Find the shaded area under the standard normal curves below. Now, when you look at this curve, this part has been shaded and this part is unshaded. And the question says we should find a shaded area. Now, to find a shaded area, this is what we're going to do. Now, when you look at the Z score here, it's positive 1.96, isn't it? So we go to the Z table and then check positive 1.96. Now to check it, there is something you need to know. The number before the decimal and the first number after the decimal are the ones at the vertical side here. And then the second number after the decimal should be the one at the horizontal side here. Okay. So to check positive 1.96, you check for 1.9 at the vertical. So we are looking for 1.9. So this is 1.9. This is 1.9. Then we look out for 6 at the horizontal. So 0, 1, 2, 3, 4, 5, 6. So this is 6, right? So we are going to check the probability that corresponds to them. So The answer is 0.9750. Even though on my table I have 0.9750, it means 0.9750. Some tables write it in full, okay? Yeah. So whenever you see 0.9750, it means 0.9750, okay? So the answer is what? 0.9750. Now look at the note I gave you earlier. I told you that whenever you check a positive z-score on a positive z table, the answer you get means area to the left, isn't it? So let's go back. We got what? 0.9750. So what does it mean? It should mean the area from this z-score to the left. So it means that the entire of this area is 0.9750. Since the 0.9750 represents the left, and we also need the left in this particular curve, so straightforward, the answer for the shaded area in the first curve is 0.9750. Let's go to the second curve. Now, the second curve, the z-score is positive 2. 2 is the same as 2.00. So it means that we are going to check for positive 2.00 on the z table. So let's go to the z table. Now, this is the positive z table, isn't it? So we are looking out for positive 2.00. So we have positive 2.0 here, and then 0 is also here. So we check. Yeah, it falls on 0.9772. Now, I told you that when you check a positive z-score on a positive z table, the answer represents the left, isn't it? So this 0.9772 should represent this left. This place is the 0.9772. But the question asks us to find the area to the right, which is this shaded portion. So to get the area to the right, since we know the area to the left to be 0.9772, then to get the right, we just say 1 minus 0.9772. And that will give us 0.0228. So that is the answer to this also. Now remember, in one of the rules, I told you that in case you go and check a positive z-score on a negative z table, the answer will mean the right, isn't it? So let's try that and see. This is a positive 2. Let's check it on a negative z table. So this is a negative z table, right? So we check positive 2.00 on a negative z table. So this is 2.00. So it will fall on 0.0228. You see that we get the same answer for the right straightforward. So you can either use the positive table or the negative table to check it, or you can use the two of them together. Now whenever you are going to write exams, they will give you the table in the exam room, okay? Now let's look at the third curve. Now when you look at this, there's a z-score here, and then there's also a z-score here. This wants us to find the area between this z-score and this z-score. Now to solve this type, this is what we do. You have negative 0.5 z-score, isn't it? So we go and check it on each negative z table. So let's go and check negative 0.5 on a negative z table and see what we will get. Now when we check negative 0.50, negative 0.5, this is it, negative 0.50, the answer is 0.3085. So the 0.3085 represents the area from the negative 0.5 to the left, which is this area. Then we go and check this z-score also on each z table. So let's go and check positive 1.5 on z table also. So positive 1.5, which is the same as positive 1.50. So we have 1.5 here, 0. So the answer will be 0.9332. So which also means since it is a positive z-score you checked on a positive z table, it also means area to the left. So it means that from this point going to the left is 0.9332. 0.9332. Okay, so to get the final answer, because we are finding the area between this and this, so to get the area between z-score of 1.5 and z-score of negative 0.5, the answer should be the area to the left of positive 1.5 minus the area to the left of negative 0.5. So that will be what? 0.9332 minus 0.3085. And it will give you 0.6247. So that is the final answer to this. So let's look at example 2. Example 2 contains 4 questions. So let's look at how to solve them one after the other. So the first question says, find the area under the standard normal curve to the left of z is equal to 1.25. So to solve this, I'm going to sketch a curve. So I have my curve, but the question says z is equal to 1.25. Remember that when the standard normal curve is divided into 2, the middle here is always 0, which represents the mean. Also, in a standard normal curve, the z-scores that are at the left of 0 should be negative, and then the z-scores that are at the right of 0 are positives. Okay, we say z is equal to 1.25, so you just sketch that. Okay, 1.25 will be somewhere here. Okay, so joy. But the question says we should find the area to the left of z is equal to 1.25. So z is 1.25, but we are finding the area to the left of it, isn't it? So it means we need this area. So to find this area, we go and check this positive 1.25 on a positive z table. So let's check it out. So positive 1.25. So we check positive 1.2 here, positive 1.25. So 0, 1, 2, 3, 4, 5. So this is 5. So let's trace it to 1.2. So that's the answer. So the answer is 0.8944. Remember, I told you when you check a positive z-score on a positive z table, the answer you get represents area to the left. Okay, so this 0.8944 represents area to the left already, and that is where we need. So we've gotten the answer straight as 0.8944. Now, question 2 says, find the area under the standard normal curve to the right of z is equal to negative 2.1. So to do this, we also sketch the curve. Now remember that when the curve is divided into 2, the middle is where the mean is, and the mean is 0. And then at the left side are negative z-scores. So we have z is equal to negative 2.1. So let's say it will be somewhere here. So we have negative 2.1, which is the same as negative 2.10. But the question says we should find the area to the right of it, not the left, the right, isn't it? So meaning we want this area, we want this shaded area. Okay, we want the area at the right here. But before we can get the answer, we need to go and check this negative 2.10. So let's check negative 2.10 on a negative z table. So we have negative 2.10. So this is negative 2.10. So that will be 0.0179. So the 0.0179 represents area to the left. Remember, I told you when you check a negative z-score also on a negative z table, the answer represents the left. But we want the right side. So to get the right, we say 1 minus the left. Okay, since the left is 0.0179, then to get the right will be 1 minus 0.0179, and that will give us 0.9821. So let's look at question 3. Question 3 says, find the area under the standard normal curve between z is equal to negative 1.5 and z is equal to 2.5. Remember, 2.5 is the same as 2.50 in 2 decimal places. Negative 1.5 is negative 1.50 in 2 decimal places. Okay, so to do this, we sketch the curve also. Then remember, the middle is always 0. Now let's say negative 1.5 is here, so negative 1.5. Now let's say 2.5 is somewhere here. Now we want to find the area between negative 1.5 and positive 2.5. So we need this area between. Okay, so we need the area between this and this. So to do that, first we go and check the positive 2.5 on a positive z table. So let's check positive 2.5. So positive 2.50, positive 2.50. This is 0 at the top here. So 0. Positive 2.50 is 0.9938. Remember, you check a positive z-score on a positive z table, so it means area to the left. Okay, so this positive 2.5 to the left is 0.9938. Okay, also let's check negative 1.5 on a negative z table. So negative 1.50, negative 1.50, 0 is on this, 0 is the first, so negative 1.50 give us 0.0668. Okay, remember, for this also you are checking a negative z-score on a negative z table, so it also means area to the left. Okay, so negative 1.50 to the left is also 0.0668. But the question says between, so that will be 0.9938 minus 0.0668, which will give us 0.9270. So the area under the standard normal curve between z is equal to negative 1.5 and z is equal to 2.5 is 0.9270. So let's look at question 4. Question 4 says, find the sum of the areas under the standard normal curve to the left of z is equal to negative 1.96 and to the right of z equals positive 1.96. So to solve this too, we are going to sketch a curve. Now after sketching a curve, remember, the middle is always 0 in a standard normal curve. Okay, now we want z is equal to negative 1.96. So let's say negative 1.96 is here, and we have positive 1.96 also at the side. But the question says the left of z is equal to negative 1.96. So where is the left? This is the left of negative 1.96. And the right of z is equal to positive 1.96. So the right of positive 1.96 is this side. But look at the question. The question says find the sum. It means that we should find the area to the left of this and also find the area to the right of this and then add them together. So let's go and check negative 1.96 on a negative z table. Now when we check negative 1.96, this is negative 1.96. So let's look for 6. 0, 1, 2, 3, 4, 5, 6. So negative 1.96 will be here. That is 0.0250. I told you when you check a negative z-score on a negative z table, the answer represents the left, isn't it? So this left here is 0.0250. We've gotten this left already. So now let's look for this side. Now to get this side, first we go and check positive 1.96 on also a positive z table. So let's check positive 1.96. So this is positive 1.9. So let's look for 6. 0, 1, 2, 3, 4, 5, 6. So that will give us 0.9750. Also remember that when you check a positive z-score on each positive z table, the answer you get is also the left, isn't it? So to the left of 1.96, the answer is 0.9750. but we want the right. So to get the right, 1 minus 0.9750, and that will give us also 0.0250. And when we add the two together, because the question says sum, so when we add the two together, 0.0250 plus 0.0250 will give us 0.05. So the final answer to question 4 is 0.05. The reason you get the same answer for the left of negative 1.96 and the right of positive 1.96 is that they are same value, just that they have different signs. Okay, so you get the same answer for them. So sometimes when you see a question like this where the z-scores are the same, just that their signs are different, if you are able to get the answer for one, you take that same answer for the other side, unless the z-scores are different. So let's look at example 3. Find the following. Question 1. Probability that z is less than 1.45. So to do that, first we sketch a curve. Now remember, the middle is 0, but we want the probability that z is less than 1.45. So before we can do that, we need to show where 1.45 is. So let's say positive 1.45 is somewhere here. But the question says less than. Now, less than is the same as left, okay? And then greater than is the same as right, okay? So since question 1 says less than, it means we should find the area to the left of positive 1.45. So to get it, we check positive 1.45 on the positive z table. So we are looking for positive 1.45. So this is positive 1.45. 0, 1, 2, 3, 4, 5. So we get 0.9265. Remember, when you check a positive z-score on a positive z table, the answer represents area to the left. But per the question also wants us to find the left. So straightforward, we've gotten the area to the left to be 0.9265. So that is the answer to question 1. So let's look at question 2. Question 2 says we should find the probability that z is greater than negative 2.58. So to get this, we also sketch the curve. Now, we have 0 at the middle, and then negative 2.58 will be somewhere here. But the question says greater than. Remember, I told you greater than means the right, okay? Less than means the left. So we are finding the area to the right of negative 2.58. First, let's go and check this negative 2.58 on its table, which is a negative z table. So negative 2.58. So we have negative 2.5 here. So 8 will be 0, 1, 2, 3, 4, 5, 6, 7, 8. So this is 8. So negative 2.58. So that will give us 0.0049. But remember, I told you when you check a negative z-score on a negative z table, the answer you get represents the area to the left, isn't it? So it means this left side is 0.0049. But we want the right. So to get this shaded portion, the right, okay, remember 1 minus left will give you right, okay, and 1 minus right will give you left, okay. So since we know the left to be 0.0049, to get the right, we just say 1 minus 0.0049, and that will give us 0.9951. So that is the answer to question 2 also. So let's look at question 3. Question 3 says we should find the probability that negative 2.25 is less than z, less than 1.25. Now, what this means is we should find the area between negative 2.25 and positive 1.25. Whenever you see something like this, it means between them, okay? So to do that, you sketch your curve also, okay? Then remember, the middle is 0. And then the z-scores at the left should be negative, right are positive, okay? So let's put negative 2.25 here. And then let's put positive 1.25 here in them. So we are finding the area from negative 2.25 to positive 1.25. So to do that, first let's go and check negative 2.25 on a negative z table. So negative 2.25. So this is negative 2.2. Then we look for 5. 0, 1, 2, 3, 4, 5. So that will give us 0.0122, which means area to the left. Okay, 0.0122. And then let's also check positive 1.25 on a positive z table. So positive 1.25. So this is positive 1.2. Then let's look for 5. 0, 1, 2, 3, 4, 5. So positive 1.25 gives us 0.8944. So which also means to the left. Remember, you check a positive z-score on a positive z table. So the answer means to the left. Okay. But remember, I told you to get a between. It should be the difference between the left of the two of them. Okay. So that will be 0.8944 minus 0.0122. And that will give us 0.8822. So the answer to question 3 is 0.8822. So let's look at question 4. Question 4 says we should find the probability that z is less than negative 2.58 or z is greater than positive 2.58. Remember, all means plus. Okay, so it means we should find a sum. So to do that, let's sketch a curve. Now, after sketching the curve, remember 0 is at the middle here. Now negative 2.58, let's say it's somewhere here. And then we also have positive 2.58 here. Okay, so the question says z less than negative 2.58. So we should find this area, z greater than positive 2.58. So we have positive 2.58 here. And greater than means the right. So we should find the right of it. Now the word or here means plus, meaning after getting this and this, then we add them together. Okay, so to do that, let's go and check negative 2.58 on a negative z table. So negative 2.58. So let's move to 8. That will be 0.0049. Remember, it's a negative z-score we've checked on a negative z table, which should means area to the left, isn't it? So this left area is 0.0049. Okay, and then let's check positive 2.58 also on its table. Positive 2.58. So positive 2.58. That will give us 0.9951. 0.9951. Now, remember, we check positive z-score on a positive z table. So that 0.9951 should also means area to the left. But since we need area to the right, we just say 1 minus 0.9951. And that will give us 0.0049. So it means that we get this to be 0.0049. And this is also 0.0049. So when we add them together, we get 0.0098. That is the final answer. Now, the reason we get the same answer for this shaded portion and this shaded portion is that in absolute terms, they have the same z-score. That is 2.58, 2.58. Just that their signs are different. Okay. But if the z-scores are different, that one you won't get same area for them. Okay. So whenever you have a question like this and then their z-scores are the same, if you're able to get this part, you can just take it as this one also and then add them together without stressing yourself much. So let's look at example 4. Now example 4 is more practical. Example 4 says a survey by the National Retail Federation found that women spend on average $146.21 for their Christmas holidays. Assume the standard deviation is $29.44. Find a percentage of women who spend less than $160. Assume the variable is normally distributed. Now, to solve this type of question, whenever a question asks you to find the percentage, the question is just trying to tell you to find the probability. But after getting the probability, you convert it to percentage by multiplying it by 100. So we want to find the probability for less than $160. So to do that, the question says average is $146.21. Okay, that is the mean. Average is the same as mean. Okay, so let's jot that down. Okay, so the mean is $146.21. Now, the question also says, assume the standard deviation to be $29.44. So, the standard deviation, small letter sigma, is $29.44. But the question says we should find the probability that x is less than $160. So, we are finding the probability that x is less than $160. We are assuming that the variable is normally distributed, isn't it? So, we are going to standardize this by converting it to a standard normal. That is, we convert this x to z. Okay, so to do that, what's the formula for z? The formula for z is x minus mu divided by standard deviation. So what we're going to do is to substitute the various values in it. You are going to consider your x as what you are finding, that is the $160. So our x is $160. Okay, and then our mean is $146.21. Okay, and then the standard deviation is $29.44. So we substitute in the formula. So 160 minus 146.21 divided by 29.44. So 160 minus 146.21 will give you 13.79. So when you divide 13.79 by 29.44, you will get 0.4684. But whenever you find a z-score, you have to leave your z-score in 2 decimal places, okay? So 0.4684 in 2 decimal places should give you 0.47. Now, how do we convert it into 2 decimal places? It means that after the decimal point, count 2 values. 1, 2. So this is the second one, isn't it? Now, before you write it, check the number after the second one, okay? If that number is more than 4, you convert it to 1 and add it to the second one. But if that number is 4 or below, you leave it like that. So, but when you see this is 8, which is more than 4. So we convert it to 1 and add it to 6. So that will give us 0.47. Okay, so in 2 decimal places, z is equal to 0.47. So now that we know z, we can now say what? We are finding probability that z is less than 0.47 instead of saying probability that x is less than $160. So we've standardized it. So it's now z less than 0.47. So now we can now sketch the curve and find a probability that z is less than 0.47. So to do that, we sketch our curve. Now after sketching the curve, remember 0 is at the middle here. Now where will 0.47 be? 0.47 will be somewhere here. So 0.47. So since the question says less than, it means the area to the left. Now to get that, we take our z table and then check positive 0.47, isn't it? So let's go and check positive 0.47 on a positive z table. So we check positive 0.47. This is 0.4. So we check where 7 is. This is 7 here. So positive 0.47 will give us 0.6808. Now remember, I told you that whenever you check a positive z-score on a positive z table, the answer you get represents the left. Okay, so this 0.6808 means area to the left. And that is where we need, isn't it? So the probability that z is less than 0.47 is 0.6808. That is the answer. But because the question says we should find a percentage, so you multiply the 0.6808 by 100%. So 0.6808 times 100% will give you 68.08%. So the percentage of women who spend less than $160 is 68.08%. So let's look at example 5. Example 5 says, the nicotine content of a brand of cigarettes is normally distributed with a mean of 2.0 milligram and a standard deviation of 0.25 mg. What is the probability that a cigarette will have nicotine content? Now there are 3 sub-questions under this. So let's take them one after the other. So the first one says, what is the probability that a cigarette will have nicotine content of 1.65 mg or less? So to solve this, remember the mean is 2.0 mg according to the question. and then the standard deviation is 0.25 mg. Now please always read the question carefully. If the question gives you variance, first convert the variance to standard deviation. Okay, to convert a variance to standard deviation, you take the square root of the variance. But the question says you should find a probability of 1.65 mg or less. So we are finding x less than or equal to 1.65 mg. So to work this, first we need to find the z-score. The formula for the z-score says x minus mu divided by standard deviation, isn't it? When we substitute in this formula, our x is 1.65. So when we put it in, minus the mean is 2, and then the standard deviation is 0.25. So 1.65 minus 2 will give you negative 0.35. And negative 0.35 divided by 0.25 should give you negative 1.40. So our z is now negative 1.40. So what that means now is that we are finding the probability that z is less than negative 1.40. So to do that, we can sketch a curve for this also. Remember, the middle is 0. And then, let's say negative 1.40 is somewhere here. But the question says less than. So, it means we are finding this area. So, we can go and check negative 1.40 on the negative z table. So, negative 1.40 is 0.0808. But remember, I told you when you check a negative z-score on a negative z table, the answer represents the left. So the area to the left is 0.0808. But according to the question, we need the area to the left also, isn't it? So straightforward, the answer is 0.0808. So the probability that a cigarette will have nicotine content of 1.65 mg or less is 0.0808. So let's look at Roman number 2. Roman number 2 says, what is the probability that a cigarette will have nicotine content of 2.18 mg or more? So here we're going to find the z-score. So to get the z-score, our x is 2.18, isn't it? Minus the mean, which is 2, divided by standard deviation. So 2.18 minus 2 will give us 0.18. Divided by 0.25, we get 0.72. So our z-score is 0.72. So we are finding the probability that z is greater than 0.72. So to do that, we also sketch a curve. Now remember, the middle is 0. So let's say 0.72 is somewhere here. But the question says greater than. That is more. Okay. So this right area is the area greater than 0.72. So to get the answer, first we go and check this positive 0.72 on each positive z table. So let's check it out. So positive 0.72. So we have positive 0.7 here, and then 2, 0, 1, 2. That will give us 0.7642. 0.7642. Remember I told you when you check a positive z-score on a positive z table, the answer means area to the left, isn't it? So 0.7642 represents the left, okay? To get the area to the right here, that will be 1 minus the left. So that will be 1 minus 0.7642. And that will give us 0.2358. So let's look at Roman number 3. Roman number 3 says between 1.50 mg and 2.25 mg. So to solve this type, we know our mean to be 2.0 mg. Standard deviation is 0.25. But we are finding area between 1.50 and 2.25. But the formula for z says x minus mean divided by standard deviation. But for this, we are going to find two z's, okay? So the first z should be what? The first x here, 1.5, minus the mean divided by standard deviation. And that will give us negative 2.00. And then we find the second z also. The second z should be the second x here, that is 2.25, minus the mean divided by standard deviation. When you put that on your calculator, you get 1.00. So it means we are finding the area between z-scores of 1 and negative 2. So we sketch a curve. Now, when we sketch the curve, remember the middle is 0. And then let's say -2 is somewhere here. And then let's say +1 is somewhere here. That is 1.00k. Now, we are finding the area between them. So meaning we should find the area in the middle here. Now, to find the area between them, you will find the area to the left of -2 and also find the area to the left of +1. After getting the two areas, then you find the difference. So let's do that together. So let's check z-score of -2.00 on the negative z table. So -2.00, this is -2.00. So that will give us 0.0228. So area to the left of -2.00 is 0.0228. So let's go and check +1 also on a positive z table. So 1.00, 1.00. That will give us 0.8413. Remember, this is a positive z-score on a positive z table, so it also means area to the left. So the area to the left of +1 is 0.8413. Since we know the area to the left for the two of them, we find the difference. So difference means the bigger one minus the smaller one. So 0.8413 minus 0.0228. That will give us 0.8185. So the correct answer for Roman number 3 is 0.8185. So you can check the description area below for exam questions with guided solution. The link is in the description area, so check it out. I'll end here for now. So if you haven't subscribed to the channel, do that now so that whenever we post new video, you can have access to it easily. Thank you.